Should we resume?
Yes, sir.
Yes.
So, okay, so we saw all these things. Now, let's talk about a very important thing, which is the fourth factor here in this thing, and which we call as catalyst. Anybody who wants to talk about what a catalyst is?
So basically, it's a substance which helps to fasten the reaction. Like,
Okay. Anyone else? Jagrit?
So, substance which helps to change the rate of the reaction without getting involved in the product.
In the process, not in the product. Very good. Very
Oh,
close. Where is Vihan?
yes, sir. I don't know. Today was a PTM and was also not there in the PTM.
All well with him?
Yes, I'll just ask him.
No, I mean, do it, Ram. So catalyst is a substance which alters the rate of reaction without getting consumed in the process, right? So a catalyst is a substance which alters the rate of reaction without getting consumed in the process. What do you need to look for? First is alters the rate of reaction. In general, yes, we use catalyst for speeding up the reaction. But can the catalyst be used for slowing down the reaction? Yes, absolutely yes. All right. Second word is consumed. Does this mean that catalyst takes part in the reaction? Yes, it does. But does that mean that catalyst is consumed, for example? No. A very easy example is, let's say you are making a pancake on a tawa, right? So is tawa used in making the pancake? Yes. Is tawa consumed in making the pancake? कि भाई दो पैनकेक बना, तवा जो है 5 ग्राम कम हो गया, थोड़ा लोहा भी खा गया उसका. ऐसा तो नहीं होता ना. Tawa is just to, like, for the heat to get transferred and that to take a proper shape, so that we can put some maple syrup or something and like feel the heaven, right? So catalyst is something which alters the rate of reaction. So we'll look at this thing 2-3 points. The 10th का syllabus इतना ही है. You just have to remember the catalyst. एक दो cases हैं which is Haber's process. वहाँ पे you have to remember कि iron is the catalyst. Then there are a couple of more things, but we will look at 2-3 other things. So let's say what happens. So there's a very famous example that suppose you have a mixture, and this mixture is of H2 and O2 in the gaseous form, right? And I have closed it, and this is at STP. So theoretically, it is said that if you keep it for even million years, nothing will happen to it. We cannot keep it for million years because we don't have million years, but it is said that theoretically, if you keep this thing for million years at STP, nothing will happen. But if you bring a platinum wire, the whole thing will blast. The reaction will happen in such a fast pace that the whole thing will blast. Now we need to understand why that is happening, right? So let's look at the energy diagram of this. That, okay, what actually this catalyst is doing. So let's say this is your energy coordinate. So I'll say that this is your energy y-axis, and this is your reaction coordinate, which is your x-axis. And let's say typical reaction goes something like this. So here we have reactants, here we have products. We can say this is an exothermic reaction because products are having lesser energy. So we know this thing and this thing. This is your this energy difference is your EA, right? So we need to have this much of minimum energy, then only the reaction will proceed. Otherwise, the reaction won't proceed. What catalyst does, catalyst gives it a alternative path. That path would be literally this, somewhat like this. So basically, because of the catalyst, we have a new value of EA, which is a lesser value compared to the previous value. Let's call this EA dash. Do you see? So when we are using the catalyst and when we are not using the catalyst, is there any change in the energy of reactant and product? No. The value of R is not changing, the value of P is not changing. So the overall change in the energy of reactant and product is not going to change at all. What is changing? The value of EA. This thing is when catalyst is used. This is when catalyst is not used. But if you look at the energy difference between reactant and product, nothing is changing. It remains the same. You use catalyst, you do not use catalyst. The change in the reactant and products of this this energy of reactant product is not going to change. Right? So I can make a claim here also that the overall energy difference of the whole reaction is independent of catalyst. For example, let's say a Natri is trying to break my head and she knows that she has to throw the patthar at 10 meters per second. Now, Garima comes and Garima says, I have found out a different kind of patthar. You throw it at just 5 meters per second, khopadi will photo 5, right? Now, you use the Naya patthar or you use the Purana patthar. At the end of the day, my khopadi is photo 5, right? So it does not matter which path you are choosing. My head is done. No, I'm like in the pain. In a very similar way, it does not matter. You are taking the catalyst path or you are taking without catalyst path. There will be no change in the reaction and in terms of energy of the product and reactant. The net energy difference of the reactant and product is independent of catalyst use. Understand? Garima, you have a doubt?
Yes, sir. Could you repeat the part just above the graph?
Yes.
Yes.
So I'm saying that we just define catalyst. What is a catalyst? That catalyst is a substance which alters the rate of reaction without getting consumed in the process. We focused on two parts. First is alters. It means it changes the rate of reaction. In general, we take it for fastening up the speed. It can also slow it down, but usually we don't require it for such process. We are also most of the research is for that only, that how do you fasten up the process, fast food industry kind of thing. The second word which you focused on is the consumption part, that the catalyst is not consumed in the process. But does that mean that it does not take part in the reaction also? No, it does take part in the reaction. And we gave the example of making a pancake, that let's say you are making a pancake on a tawa, right? So if I say that tawa was not a part of the whole pancake making, it's a false statement. But if I say that with pancake you ate 5 grams of tawa also, that is wrong. No, that will be very weird. Tawa remains tawa only. We are not eating tawa, but we are using tawa to make the pancake. In a similar way, catalyst actually just provides a surface for the breaking of the older bonds, and so the new bonds can be formed. That's it. It basically, in most of the cases, it lowers the energy barrier. It lowers the activation energy, which we can see here. Understand?
Yes, sir. The part where you've written STP, could you tell what that is?
STP stands for, anybody in the class wanna talk about what is STP?
The standard temperature pressure.
Yes, STP stands for, what's wrong with this? This is for standard temperature and pressure. So what is the standard temperature? This is 0 degrees Celsius or 273 Kelvin. And what is that pressure? 1 atm.
1 atmosphere.
This is the condition. So if you keep the whole thing at that condition, nothing will happen to this. Understand? Any doubt so far?
So,
Yep.
so you said that the difference between the energy of the reactants and the products is the activation energy, right?
No, the difference between the this intermediate complex and the reactant, that is activation energy. You see, this part, this is your intermediate complex, right? This part here is your
Yes, sir.
reactant, and the activation energy is basically the gap between reactant and the intermediate complex. I'll explain in a very simple term. For example, all of we have these plans कि बस 8 बज जाए फिर हम पढ़ना शुरू करेंगे और फिर हम घड़ी देखते हो it's like 8:05 like अरे यार अब 9 बजे से पढ़ेंगे we'll start at the dot 8 or 9 or 10 like और कभी कभी ऐसा होता है ना कि ऐसे जोन में नहीं आ पा रहे, ऐसे जोन में आ जाए तो फिर पढ़ना शुरू कर देंगे कि हमने ऐसे लाइक कि सपोज हम पढ़ रहे इतना बैकलॉग होगा कि पढ़ ही नहीं पा रहे हैं, तो वो बस वो बैकलॉग क्लियर हो जाए फिर पढ़ना शुरू कर देंगे. तो ये जो वो कंडीशन है बस यहाँ तक हो जाए उसके बाद से पढ़ना शुरू कर देंगे खुद से. तो जो यहाँ तक हो जाए दैट इज इंटरमीडिएट कॉम्प्लेक्स. वहां पे आपके पास अच्छे बच्चे के भी उतने ही गुण हैं जितने एक नॉट सो अच्छे बच्चे के गुण हैं, राइट? तो उस टाइम पे सेपरेट करना बहुत मुश्किल, बस वहां तक पहुंच जाओ कैसे तैसे करके, उसके बाद खुद ही पढ़ ले जाओगे. तो दैट इज व्हाट दिस एक्टिवेशन एनर्जी इज लाइक कि रिएक्टेंट एंड इंटरमीडिएट का उसके बीच में जो एनर्जी का गैप है ना उसको कहते हैं एक्टिवेशन एनर्जी. और कोई डाउट?
Yes, sir.
So let's revise what all did we what all the factors did we do. So the first factor, वो काफी कुछ कर लिया आज हम लोगों ने. The first factor which we saw was temperature, okay, and the second factor which we saw was temperature probably, I guess, right? Temperature तो पहला था. Then we saw another form of energy that will be, yeah, presence of light. This was the second factor which affects the rate of reaction. Then we saw electricity which affects the rate of reaction. Then we saw catalyst which affects the rate of reaction. Now how many of you want to go to sleep, because I think it's 11 in India, I guess. इधर तो 8:30 ही बज रहे हैं. But how many of you like to go to bed के सर? अब तो अच्छा बच्चों में जल्दी सो जाता हूँ आजकल, जल्दी उठता हूँ. No Netflix, no social media, sir. There's a one tiny topic remaining. If you are okay, I can complete that also, or we can go for the next class, whatever you guys say.
Sir, go on with it.
Those who want me to go on, just show a raise of hand. 2, 3, 4, 5. ठीक है, छोटा सा टॉपिक है, हार्डली 2-5 मिनट लेगा. ऐसा मैं कह
Sir,
रहा
I
हूँ.
would have.
या टेल मी.
So for the factors so we can also say that instead of temperature, presence of light, and presence of electricity, we can just categorize them as energy, right?
हाँ, कह सकते हो.
Okay, sir.
सबका मालिक एक है, कोई भगवान बोलता है, कोई अल्लाह बोलता है, कोई जीसस बोलता है, कोई कुछ बोलता है, किसी एक को फॉलो कर लो, सब हो जाएगा। अब ऐसा जरूरी थोड़ा कि तुम बिजली मत दो तो मतलब पानी नहीं टूटेगा। तुम पानी को हीट करो 3400 समथिंग डिग्री सेल्सियस, इफ मेमोरी सर्व्स राइट, वाटर विल ब्रेक डाउन।
Sir, what state would that be?
Gaseous state only. So there's a possibility of thermal decomposition of water. That water will break into the atomic components of which is oxygen and hydrogen. हाँ, ये अलग बात है कि at that temperature the energy available is too much that the electrons will be kind of excited and they will leave the atom, and that eventually it will come in the form of plasma. But water can be broken down without electricity also. आप heat दे के भी कर सकते हो water को, but heat will be very high. अच्छा ना, ऐसे करंट थोड़ा सा छुआ दो, काम हो गया अपने, क्या दिक्कत है, right? So last topic which affects the rate of reaction is pressure. It's a very small topic. See, pressure in a way, for example, that all of you went to IIT Bombay or IIT Delhi or AIMS Delhi or whatever college you guys want, and in the first year you guys are very happy, you are very talented people, right? So you did not study for the whole semester. And then comes the D-Day कि भाई कल तो एग्जाम है, क्या करें, फेल तो नहीं हो सकते हैं, अच्छे मार्क्स चाहिए, और जिंदगी मौत की बात है, उस रात को बहुत सारी पढ़ाई करनी है. सो यू सी द अमाउंट ऑफ प्रेशर यू गाइस हैव. सो at that night you will do something which is unimaginable. At that night you will complete the whole syllabus of the whole semester. हो जाता है, बहुत आराम से हो जाता है. Why? Because pressure is so much. So if the pressure is so much, a lot of good reactions can also happen. Now ये तो रही नॉर्मल लाइफ की बात है. कि ऐसे अगर मैं साइंस की भाषा में बोलूँ तो ऐसे भी समझ सकते हैं कि सपोज करो मैंने बोला प्रेशर बहुत ज्यादा है, इसका मतलब जो पार्टिकल्स है ना वो बहुत ज्यादा पास में बहुत ज्यादा टकरा रहे हैं आपस में, तभी तो प्रेशर बहुत ज्यादा है. टकरा रहे हैं मतलब फोर्स बढ़ रहा है, फोर्स बढ़ रहा है मतलब फोर्स पर यूनिट एरिया बढ़ रहा है, फोर्स पर यूनिट एरिया बढ़ रहा है मतलब प्रेशर बढ़ रहा है, राइट? सो इफ प्रेशर इज टू मच इट मीन्स दैट कोलिजन की पॉसिबिलिटी भी काफी ज्यादा हो रखी है, और अगर कोलिजन की पॉसिबिलिटी काफी ज्यादा हो रखी है तो रिएक्शन आगे बढ़ेगा. सो देयर आर so many reactions which happen at high pressure only, which do not happen at low pressure. A very famous reaction is if you take N2 and if you take 3H2, so you have to give it around 200 pascals. It's a huge pressure, and 450 degrees Celsius or 500 degrees Celsius. When you do this, then only what do you get? Ammonia, 2NH3, and this is called Haber's process. And here the catalyst is, if the memory serves right, this is finely divided iron. So catalyst here is iron, finely divided or powdered form. We take the catalyst. So what वो बस ये याद रखो कि catalyst iron है, form अभी नहीं पूछेगा. So what you have to remember, this process is called Haber's process. High pressure, high temperature, catalyst is iron. In the funny story behind this, so this Haber was a German guy and Hitler told him to create a bomb. And he was trying to make bomb, but bomb नहीं बना था, ये ammonia बन गया था. And this nitrogen is very crucial factor in most of the bomb making. In fact, if you look at your this seat belt बोलो, airbag जो होते हैं ना कार में, तो कार में जो airbag हो रहा है वो क्या हो, एक तरीके से मिनी बॉम्ब एक्सप्लोजन ही तो है, right? It's just you are containing that explosion, so that is making the whole balloon thing inflate and saving your life probably. So something of that sort. So I think this will be all for today. Your task for the next class is finish the NCRT reading, because in the next class, what we will do, we will talk about basic things. What is reactant, what is product, balancing कैसे कैसे करते हैं, चारों टाइप, उसके combination क्या होता है, decomposition क्या होता है. I mean, you guys know it, but ठीक है, for the sake of it,
We are already on third chapter, sir.
don't worry. Then we'll so basically in the next class we'll finish the NCRT, your syllabus, and then I'll take one more lecture. There I'll teach you redox. what is oxidation, what is reduction. We'll go with the basic definition, but I'll tell you one more thing, which is how do we calculate oxidation number. So we will learn that how do we calculate oxidation number. So in the next class when we meet, I'll give you the homework to read certain things, the certain rules for calculating oxidation number. Once you know the oxidation number, then it's a piece of cake. So if you are saying that this thing is done, so all of you have solved exemplar of chapter 1.
Yes, sir.
Very good. Take let's meet at the next. So we meet again Sunday 9 baje, right?
Yes, sir. Exemplar is also done. Module is also done.
Arey wah, such good people. Chalo, see you guys. Bye bye.
Bye,
Bye,
sir.
sir.
Have a nice day.
Good night.
Sir.